this session, we'll be discussing a gradient descent. This gradient descent is an algorithm which is used to find the best values of parameters like the weights, bias by minimizing the error. So basically, in simple words, we can say that it is a method used to reduce the error, improve the predictions, and to find the best fit model, right, in order to classify or predict the outcomes. So let me take a real life scenario. If you are standing on a mountain and you want to reach the lowest point in the valley, in that case, what you will do? The first step, you will check with the slopes, right? First, you will check with each and every slope which is more nearest, and then you will move downwards step by step in order to reach the lowest point value. This is how exactly the gradient descent will works. In machine learning, the mountain is said to be nothing but the error function, which uses a method called mean squared error. This actually is a error function. So you're standing on the mountain. Assume that mountain is an error function which uses the technique of mathematically mean squared error. And the lowest point which you are seeing, right, the slopes, is nothing but it is minimum error. And each and every step which you are taking is nothing but you are updating the weights. This is how we can relate the example with the machine learning process. So the core idea here is we have to adjust the parameters in such a way that error decreases step by step whenever you are moving to the next process. So the main formula which is used for the error correction is the new value, right? Whenever you are moving to the next step, you are reducing the error. So how we are finding it? The formula new value equals, you have an already a old value or initial value at first, that should be used as an old value, minus eta, that is nothing but a learning rate, into the gradient value, right? So this is how it works. This eta is nothing but a learning rate, and gradient is nothing but the direction of maximum increase in the error, right? So the important rule in gradient descent is the positive gradient is nothing but you have to decrease the value. If the gradient is negative, you have to increase the value. This is what you have to do in gradient descent. So basically the steps in the gradient descent is, first you have to start with the initial values. If no initial values are being given, we can take the initial value of weights and bias from 0. We can start from 0 as the initial value. And the second step is you have to predict the output, and then third is you have to calculate the error, and fourth you have to find the gradient, and then fifth is you have to update the parameters, and sixth you have to repeat this process, the 5 steps, until error is being minimized. The main target is you have to minimize the error and increase the learning rate and accuracy of the classification of the prediction. And now the question is, why is it used? Because we cannot directly find the best values in the complex problems, so we have to iterate and improve step by step. That's why we are using the gradient. It is actually used in the very complex kind of scenarios. Right. So gradient descent is an optimization algorithm used to minimize the loss function by iteratively updating the parameters in the direction of negative gradient. This is what the basic definition of gradient descent. So first you have to find the error, and then you have to check the slope, you have to move opposite, and you have to repeat until you reach the minimum point, right, as per the example. Now we have a solving problem that should represents how this gradient descent works. Here in this example, we will be using linear regression. So using this linear regression, how this gradient descent is actually going to solve the given data points, and how it is going to minimize the error, and how it is going to reach the perfect model. That is what we are going to share. So as I said initially, if no values is given, you have to start with weights and biases 0 initial value. If any initial value is already mentioned, then we can use that as the initial value. So here I have taken the initial values of weight and biases 0 directly, and then the model gives you y equals, since this is a linear regression, we have taken y equals mx plus b. Instead of m, we have used w here because we are performing the neural network where the weight plays a major role. So we have make it as Wx plus B. So now we are going to solve this problem using gradient descent. The learning rate which is given is eta equals 0.1. Now we have the data points which is having the values as x and y. They have given x and y value. So x is 1, y is 2, x is 2, y is 4, x is 3 and y is 6. Now here we have minimum error using mean squared error. The mean squared error formula is depicted here, right? 1 by n summation of y minus y, the predicted y of square. This y is actually the value which is given over here, and this predicted value that we will find now. What is the value of it? So this predicted value uses the formula Wx plus b. We'll start with calculation. So in step 1, first we will go with finding the predicted y. So what is the x value we have? 1, 2, 3. Right, let me write this. 1, 2 and 3. What is the y value we have? 2, 4, 6. We have y is 2, 4 and 6. This is actual y. Now we will go with predicted y, which is represented by y2. So what is the formula that is used for this calculating this predicted value? Wx plus b. Right. You can directly apply the values over there and you can find the final value of the predicted y. Now y equal to mx plus b. So what is the value of w? So I replaced m by w. So weight is initially 0. And what is the x value? We are calculating for this 1 plus. What is the bias value we have? Bias is also the initial values we have fixed as 0. So we will take it as 0. It is nothing but 0. So the predicted value is 0 here. And next we will have 2, 4. So we will use this formulate for the prediction. What is the w initial value? It is 0. X is 2 plus bias is 0. We will have 2. Sorry, 0 into 2 it's 0. Have 0. Similarly, for 3 and 6 if we calculate, this is also 0 and this is also 0. 0 into anything is 0, so we will get 0. So all the values of the predicted y is actually 0. Now we have completed step 1. We have predicted the value of y from the actual y value. Now step 2 is you have to find the error. That is, you have to compute error using mean square error value. As I already told you, the formula for the mean square error is nothing but mean square error equals 1 by n summation of y minus the actual y minus predicted y the whole square. So at the rate 1 divided by n is nothing but the number of samples. We have the number of samples as 3. So 1 by 3 summation of y minus y the whole square, right? So 1 by 3. So I'll take all three values. What is the y value here? We have it is 2. The predicted value y is 2, 0. So we'll take 2 minus 0 the whole square plus its summation. So I'm going to add up all the values of it. It is 4, 0 and here it is 6, 0. We'll take that value 4 minus 0 the whole square plus 6 minus 0 the whole square. If I calculate this, I will get 4 plus 16 plus 36. So I'll get 56 divided by 3, which gives us 18.67. So the mean square error value for the given sample is 18.67. This is the error rate. Now, in step 3, I have to find the gradients. Right? Once you have found the error, you have to minimize that. That is the work of gradient descent. So now this gradient with respect to w can be written as equals minus 2 divided by n summation of x y minus the predicted y. Right. So now I can get the value minus 2 divided by n is nothing but the number of sample 3, and the summation of y minus predicted y. So this is what the value actually we will get. Right. So we'll multiply it with x. What is the x value? 1. X value is 1. We'll take 1 because we have x into y minus y predicted. Y minus y predicted. 2 minus 0. We'll take 2 minus 0 plus. And what is the next x value we have? We have the value of x is 2 and 4 minus 0. So we can take 2, 4 minus 0 plus. What is the next x value? We have 3. This is 2, 6 minus 0. So 3, we have 3, 6 minus 0. So if I compute this, I'll get minus 2 by 3 into 1 of 2 plus 2 into 4 plus 3 into 6. This will give me minus 2 by 3 into 28, which gives me minus 8.67. Right? This is this we have calculated with respect to w, the weight, and we have the other parameter called bias. Right? With respect to bias, if I calculate this is b, right, equals minus 2 divided by n summation of y minus y prediction. And this is what the formula which is used for gradient descent, for calculating the gradient descent error with respect to bias. So I'll do it for the given data sample, total 3 samples, and for y minus y naught we have 2 minus 0, 4 minus 0 and 6 minus 0. So we will have 2 minus 0 is 2 plus 4 minus 0 plus 6 minus 0. So in this case we will get minus 2 by 3 into 12, which gives you minus 8. So with respect to b, the gradient descent error rate is minus 8, and with respect to w, the gradient descent gives you the error rate is minus 18.67. Now we have found the error rate with respect to both the gradient with respect to weight and bias. Now step 4 is you have to minimize the error, so that by updating the parameters you are going to minimize the error. So how I can update the value of w here, because I have the old value. Right now you are going to find the new value. What is the formula that we have used here? New value equals old value minus learning rate into gradient. What is the learning rate we have fixed here? It is 0.1. What is the old rate we have? W equals 0 and B equals 0. That is what is going to apply here. So new value equals old value minus the learning rate into the found gradient with respect to weight and bias. This is what we have to update here. So what is the old value we have for weight? It is 0, right? The initial value, the old value which we have is 0. Minus, what is the learning rate? It is already given as 0.1. And into, what is the gradient value with respect to W we have? With respect to W we have minus 18.67. That's what is written as minus 18.67. So if I calculate this, I'll get a value here 0 plus 18.67. It's nothing but 18.67. So the new value of 18 is, this is the new value, updated parameter of the weight. We have found the error, we have calculated the gradient descent with respect to weight and bias, and then we are updating the weights for as a new weight, right? And for that we are using the old weight minus learning rate into the gradient value with respect to W, old value of W. And with respect to B, we have the previous, the initial value is 0, old value, minus what is the learning rate we have, 0.1 into what is the gradient value with respect to B, it is minus 8. That can be applied here, minus 8. So 0 plus 0.8, we will get 0.8. So the new bias value which we have updated is 0.8. So now the final updated value we have is W equals 1.867 and B equals 0.8. Alright. Just I have shown you the first iteration of the gradient descent. So basically, I'll recap it. We have an initial value, right? First, you have to find the new y value for the given data points. So for that, we have y equals mx plus b. The m have been replaced with w, and we have calculated all the new y values here. And after found the y value, step 2 is you have to compute the error using mean square error. So mean square error formula is here. We are directly applying it from the table, the direct values, and we got the mean square error value. So after finding the mean square error value, you have to compute the gradients. So the gradient with respect to weight and bias, I have the formula here. I am going to apply the values in the formula. For with respect to W, what is the gradient, and with respect to bias, what is the gradient value that we have found. Once we have found it, we have to update the weights. We have found the errors, and now we have to update the weights in order to make it the right classification or prediction model. So now this follows the formula, new weight equals old weight minus learning rate into the gradient descent with respect to W. Similarly, for bias, we have to find a new bias equals nothing but the old bias minus the learning rate into the gradient descent with respect to the bias. So we found both the values. This is the final updated value after iteration 1. This is how step by step you have to update the value. If the gradient is negative, the value should be increases. If the gradient is positive, the value will decreases. So negative gradient increases the value, positive gradient decreases the value. So current model predicts 0 for all points. Actual values are 2, 4, 6, which are too low. So the model increases the scope and increase the intercept. That's exactly what happened here. The W and B, initially it is 0. Now the W is 1.867 and B equals 0.8. It increases actually. Right. So what I said, if the gradient is negative, increase the value. If the gradient is positive, we have to decrease the value. Right. So increase the slope and increase the intercept is what is actually happened. W is nothing but it represents the slope, and B is nothing but it represents the intercept in the linear diagram. So, actually in step 4, we have moved the weights slightly in correct direction using the gradients. This is what has actually happened in gradient descent. So basically gradient descent helps us to find and update the weight, the slope and intercept or weights and bias based on the old values. Thereby we are correcting the error and making our model to fit into correctly predict or classify the given samples. Thank you.